On the recording.
This is a no playground ground.
My technology is freaking out today. So, we're getting through. We're going to be all right. All right, so our first chapter, chapter 1, we went through everything and it was expressions. We had no equal signs at all. We weren't solving, we were simplifying. We could only multiply by ones because they were fractions. So what we're going to be getting into now for chapter 2 is we're going to start working with equations, which is when we have two expressions that have an equal sign in between them. And we're looking for solutions. We're going to be getting all the way down to like nx equals a solution, an answer that we find that is also sometimes called a root. Again, those should be words we know, hopefully. If you want to have them, you can have them, but like, we know those words. We know those words. So let's get into some, holy marks, what's up with some things? And we can clear the things. Erase off. There. Erase. Oh. Love that. That's fun. Those weren't there. Oh my gosh. See what I mean by my technology causing a fit? Come on. Give me a fresh one. There we go. There we go. That's what I'm talking about. Like they're in moods today. Like they don't want to work together. They don't want to talk to each other. They're just in moods.
Oh.
But we're getting through.
Big number.
All right. So we've got a couple equations up here, and we are asked to solve. So I'm going to give us a little barrier just so we're really clear. These are two separate problems. But at least my pen is not giant. Felt like I was writing with like a bingo dauber. Like last period they were stuck with like numbers that were like this big. It was just crazy. All right. So this should hopefully not be super duper foreign of a concept for us. Looking at this left-hand set of equations, what are we going to do to try and solve this? Yeah, absolutely valid strategy. There are many paths through when we are solving. If your brain wants to go in a different order and you wind up at the same answer, you're probably fine. There are many paths through. Distributing is one that is kind of the most common on this one. So we're going to distribute this piece here. That's going to give us our 4x plus 5 on this side, which we didn't change. And on the right-hand side, we have minus 6x plus 12. Ooh, I feel like I meant a little bit in the opposite extreme. I'm making that small. Bless you. Because we're trying to solve. We're trying to get all the way down to an x equals. So what can we do to get to an x equals here? X is on one side, numbers on the other. So what are we going to do specifically? Add 6x. You will wind up with fewer negative numbers if you always move your smallest piece. That is not a math law. That is just an ease of use. You can absolutely move the 4x. You're just going to wind up with more negatives. So we're going to start with adding 6 to x to both sides. That's going to leave us here with 10x plus 5 equals 12. What are we going to do next? Subtract 5 from both sides. That's going to give us that 10x equals what? 7. So what does x equal? 7 over 10. Ta-da! We did it. Like I said, starting out simple. 0.75 as well. We're not going to usually need to switch them into decimals. especially since we don't have calculators, sometimes they're going to be super gross. We're not going to do that all that much. But if you want to and you can, absolutely go for it. Totally fine. All right. Now we're going to go up to the top and look on the right one. Now we've got some other things. What do we need to do here? Fix my iPad. I can come stand over here.
Multiply it.
Yeah. Square the pieces, multiply it out. The one thing we can't do on this one is square root both sides because we have that addition. So however you want to think about it, multiplying it out, squaring the things, do the stuff. Okay? So we're going to multiply out this piece. What do we get when we multiply out our x plus 3 squared?
X squared plus 6.
X squared plus
6.
6x. Don't forget those middle pieces. Now plus 9. If you need to, do it as our x plus 3 times x plus 3, because that's what it means to multiply by itself. You can do it like this, x plus 3, x plus 3. Distribute it out. Do not forget that middle term. Really, really important. So then we still have our plus 5 here. And we're going to do the very same thing with our x minus 2 squared. If you need to, write it out. X minus 2 times x minus 2. So when we multiply it out, what are we going to have? Minus 4x plus 4. Then what are we going to do? Combine like terms. I've got a 9 and a 5 here, and those being next to each other makes me a little uncomfortable, so let's fix them. So we've got our x squared plus 6x plus, what was it? 14. And we have x squared minus 4x plus 4. So we've combined our like terms, and sorry, I made that very small. I will go bigger on the next line. Now what can we do? We can try moving everything to the left side. We don't necessarily have to, but we could. So let's move everything to the left side. So when we say move everything to the left side, how are we going to do that specifically? So we're going to add our 4x to both sides. Minus 4 and minus our x squared. So this is the exact same process we were doing over here. We're just doing all 3 moves in one step. So you can do them in separate steps, you can do them in one step. Why did we decide to move everything left? Because I heard several people say that. Because we have an x squared and we want it to equal to 0.
Oh, we want it to equal to 0.
So let's see what happens when we move everything left. We have our x squared minus x squared. How many x squareds do we have left? 0 x squareds. So then we're left with our 6x plus 4x giving us 10x. 14 minus 4 gives us 10. And on the right-hand side, we're down to 0. So did we need this one to go all the way to 0 on the right-hand side? No. Is it fine that we went all the way to 0 on the right-hand side?
Yes.
Totally. What are we going to have to do now, though, to solve it?
Subtract 10.
Subtract 10 from both sides. So we're going to have to move one thing back. Because our x squareds canceled out, we don't need it to equal 0 anymore. So we're going to subtract 10 from both sides. And that's going to give us that 10x equals negative 10. So what does x equal? Negative 1. Okay. Hopefully, at least a little bit vaguely familiar. Questions on these two? Because I don't think I can actually save the ink. I'm taking this. Whoa. That is not what I meant. There we go. Yeah, I was like, I have it, so I can put it back up if we need to, but it's not going to stay up there because my screen's in a mood. She's in a super mood. All right, so here's our next two. I'm going to give us a barrier again because I know, especially with these fractiony ones, sometimes it's hard to tell. So we've got 3 over 2x plus 5 equals 7 over 2x minus 4. I think I jumped a page.
Yeah, I think you did.
I did.
I saw something else before.
Yeah, I jumped a page. We'll do those ones in a minute.
I agree.
I was going to say, you can cross out or you can come back to it in a minute and just leave yourself a little space. Sorry, again, my screen is in a mood and it's just one of those days because I also forgot my coffee. Like, it's just one of those days. So, we're at a couple of easier ones before we jump straight into the ones that have rationals in them. This is the same vibe to what we just did. This is the same vibe to what we just did. I just have, instead of squares, we have binomials to multiply. We're going to follow those same steps. We're going to multiply out our pieces so that we can try and combine some like terms so that we can simplify. So looking at our left-hand side up here, we've got our x plus 3 times 2x minus 5. We need to multiply this piece out. What do we get when we multiply this piece out?
2x squared minus 5x plus 6x minus 15.
2x squared.
Which technically is 2x squared plus x minus 15.
Yeah, so you can either write it out uncombined and then combine your like terms, or you can do it all in one step. Either way is fine. Just because you set it up that way, I'm going to do it your way first. Plus 6x minus 5x minus 15. So we're just doing our distribution. On our right-hand side, when we multiply this out, we got to multiply this guy out. What are we going to get? X squared minus 6x. And then we have that plus 1. So again, very similar to vibe to what we just did. I have x squareds we're trying to solve, so we need to get it to equal what? 0. So since I have 2x squareds on the left and only 1x squared on the right, I'm going to move everything to the left so that we wind up without a negative x squared. That is, we never want to wind up with minus x squared. So I'm going to subtract everything from the right to the left. So I'm going to subtract my x squared from both sides. I'm going to add 6x to both sides. And I'm going to subtract 1 from both sides.
X squared plus 5x minus
Slow down on your x simplification because we have 3 like terms to combine together on our x's. These 3 pieces all combine together. So we have our x squared plus how many x's? 7 x's minus 16.
I thought my plus was a subtraction.
Yep. As I'm going to say, just go slow and be careful. All right, so now that we have it equaling to 0, how can I try and solve a quadratic? Solve by factoring is an excellent option. Let's see if it works. So we're going to try and factor it. We're going to do our A times C is negative 16. Our B is 7. Is there a pair of numbers that multiplies to make negative 16 and adds to make 7? No. So this is not factorable. Uh-oh. How do I solve a quadratic that is not factorable? Quadratic formula. Oops, hang on, we can resume. Which is our x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That is the classic song. If we don't have that in our brains, if you would like a different one, because that one will stick in your brain for an eternity, because literally I learned that in 6th grade. There are many, 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 many songs on YouTube that have been done with a cover of the quadratic formula, including several modern artists. The pièce de résistance would be the one that was a Dre cover. I do believe it was Superman. That was quadratic formula. So if you would like a different song for quadratic formula for you to remember, I encourage you to go enjoy the supreme beauty that is the chaos of quadratic formula songs on YouTube. They are so bad, but in the best ways. Like they're not great. Like they're not good, but they're so good. Like it's like watching something crash down. It's fantastic, but in a bad way, but in a good way. Okay? So if you don't have this in your brain and you would like a different song to remember it, I encourage you to check them out on YouTube. They're so excellent. It is definitely worth falling down the quadratic formula whole song in YouTube. Like, they are primo. So we're going to substitute our values in. We've got our A, our B, and our C. So we're going to have our x equals, and we're going to put together a quadratic formula. We have the opposite of our b. Our b is this 7 here. Then it's plus or minus the square root of b squared minus 4 times our a. What's our a value? 1. Thank you. Just being clear. Times our c, which is negative 16. Careful on that sign. Divided by 2 times our a, which is that 1. I try my best every time to write it out kind of color-coded like this, so we can find our A, we can find our B, we can find our C. If that helps you, great. If it doesn't help you and you want to simplify as you go, 100% okay. Because we're going to simplify this as much as we can. So we have our negative 7 on the outside, plus or minus the square root. 7 squared is 49. 4 times 1 times negative 16 is negative 64. So 49 minus negative 64. I'm going to write it this way. So I'm just simplifying our discriminant here. 49 minus negative 64. What is our simplified our radical going to be? What's in our radical hand? 49 minus negative 64. 113. Because the minus negative becomes a plus. So 49 plus 64 is 113 over 2. Did I say we had to have our answer as a decimal? No. Are there any perfect squares in 113 that we could simplify out? It's like, well, I was like, when in doubt, think through, all right, does it divide by 4? No. Does it divide by, our next perfect square would be 9? No. Does it divide by 16? No, because it definitely doesn't divide by 4, so we know it doesn't divide by 16. Does it divide by 25? No? And by that point, if it divided by 25, 25 would be 100, and so we know it's not going to be 113, so we don't have to go further. So when in doubt, check your first 4 or 5, and usually that'll cover your bases. Okay? That's our answer. We are leaving them in simplified radical form. This is our simplified radical form. It's important to check because occasionally we will have parts of the fraction that we can simplify, but not on this one for sure. What's up, Nate? Because we had to add it to the 49. So we can't do the square root before that. So we have to add those together first and then do the square root. Oh, but, Okay. So yeah, that one's a little gross. And then we look at the right one and we go, ooh, because it's fractions, and we don't like fractions. Yeah, right? If you are comfortable with your fractions, you can absolutely plow ahead exactly the way we've done before. Get your x's together, get your numbers together. But a lot of us look at that and go, fractions. I don't want to do fractions. There is a way to make it have none fractions. Better than decimals. Multiply by your denominator. So first denominator I see up here is I've got a 4. So I'm going to take this 4 and multiply absolutely every piece of this equation by that 4. So I'm going to take this guy times 4, this guy times 4, this guy times 4, this guy times 4. Absolutely everybody. We are out of our expressions where we had to multiply by ones. We have an equation, so as long as I do the same thing to the left side that I do to the right side, I can do whatever the heck I want. I can multiply by 4. When I multiply by 4, this one and that one cancels out, and we're left with 3x, and we've gotten rid of a fraction. We're going to have plus 20. This fraction doesn't quite disappear, but I got 2 times 4, which I can do, which is 8 over 5x minus 4. Yes. It's it'd be like multiplying by 4 over 1, and when we multiply fractions, we multiply across. But I still have a fraction. Do it again. We can do the whole thing again to get rid of the other fraction. I've got a denominator of 5. If I multiply both sides by 5, multiply every piece by 5, I can do that as long as I hit everybody. So multiply this guy by 5, this guy by 5, this guy by 5, and this guy by 5. It's going to do the same thing with the fraction. My 5s cancel out. This 5 and this 5. So this guy's just going to be 8x. And we just have to simplify all the other pieces around it. So we have 8x minus 20 on one side. And on the left-hand side, we have our 15x plus 100. So our numbers are a lot bigger, but no fractions, which usually makes us a lot more comfortable. Not saying it's the only way through. Again, a gazillion pathways through it. You can totally do this without multiplying by any denominators, but it's a lot harder. We're a lot more comfortable with these kind of linear expressions. Because what are we going to do here to simplify this? What's our next step going to be? Minus the 8x on both sides. Because I want to get my x's together. What else are we going to need to move? The 100. Because I want x's on one side, numbers on the other, because I only have a linear equations here. I don't have any x squared, so we don't need to make it equal 0. We're going to subtract 100 from both sides. So what are we going to get as we simplify this? What is 15x minus 8x? 7x. Whoa, wrong pen. 7x equals negative 120. So what does x equal? Negative 120 over 7. Which if you did this in our fraction-y fraction form, you get the exact same answer, just it'd be a little harder. Okay? And that's our answer. Oh, it's going to be a grum. There we go. Ah! Oh. That's all. Where did it go? I love this so much. It's so much fun. Whoa. Okay. Now it's being a crazy pants again. There we go. All right. So questions, I can put it back up if we need it. Questions on those two before we move on to a couple a little bit weirder. Okay. So these are very similar to what we've been working with the past couple of days. And you can approach them the exact same way we approached our rational functions. Especially the one on the right. But we don't need to. We just talked through another tool we can use when we're working with rational functions. So I'm going to give us our little barrier line. Our two separate problems here. Except I need more space for the right one than I do for the left. So I'm going to give myself a different barrier line. There we go. So we can approach this exactly the way we just did. I see fractions and we go, ew. Multiply by your denominator to both sides and we can get rid of the fractions. 100% valid. So I can come in here and I can multiply both sides by the 2x plus 5. If I multiply this side by 2x plus 5, and I multiply this side by 2x plus 5, what happens over here? They cancel out. So this cancels out. If I multiply both sides by this denominator, I'm going to put it above. So times our 2, I'm just going to write next to it. So we have our 2x minus 4 times this side, and 2, what's up? Give me like another 5 seconds, okay? Because if I multiply by both sides by 2x minus 4, what happens to these two pieces here? They cancel out. So this piece cancels out. So what we wind up with is this numerator times that denominator. And this numerator times that denominator, which is exactly the result of what we get if we do cross multiply without it being magic. And why it works. What you're doing is you're multiplying by the denominator. So ever since you started doing cross multiplication, you did multiplying by the denominator. They just canceled out and your teacher didn't show you the middle step and made it magic. So it is the exact same thing as cross multiplying. It's just showing us why. Because I like to show you guys why instead of a magic trick. So once we do that, multiplying by our denominator thing, my left-hand side becomes what? What does this simplify down to? 6x minus 12. And we have that equal to 14x plus 35. Multiplying by our denominators gets rid of the fractions and make these way less gross. What are we going to do here to finish solving this? I don't have any like terms on the same side right now.
You
Subtract the 6x. Excellent start. Totally valid move. Minus 6x. Leaving us with negative 12 equals 14x minus 6x gives us 8x plus 35. Then what are we going to do? Subtract the 35. And we wind up with negative 47 equals 8x. So our answer for x is, what does x equal? Negative 47 eighths, or negative 47 over 8. Before you turn your pages, because I just heard about your turn, we have one last thing we need to do on this one. Because we started with x's in the denominator. We need to make sure that this is not an excluded value. So 47 over 8, or negative 47 over 8. Negative 47 over 8. If I substitute that in for x, will it make my denominator 0? No. Do I care what value it actually is? No. Just all I care is it 0 or is it not 0? So if I plug it in here, it's not going to be 0. If I substitute this in here, will that be 0? No, but it is important to check. So the way you can show that you checked is just check.
And then how do you know when to do that?
If you had x's in the denominator.
In anything?
Ever.
So the next one.
Yep. We have to make sure our denominator is not 0. And you can write checked, denominator not 0, or you can just put a check mark. It just lets me know we thought about it, we looked, my denominator's not 0. Okay? Let's look at the right one. Whoop. I'm with you. We can do the exact same thing here. But if I just pick and multiply by all my denominators, it's actually going to make it harder than it needs to be. So instead of multiplying by all the denominators, we want to multiply by the least common multiple, just like we did in rationals when we were dealing with that yesterday. So look for our least common multiple in our denominators, which is 100% what we did on the last one. We just didn't give it that name.
Can we look for the least common multiple when we're adding or subtracting?
Yes, we can also do that. We did multiply by our least common multiple over here, so it's the same thing we did. I'm just putting the name back on it. So looking at these ones on the right, what do we notice before we just start flying through? GCF of 3, heard it from a couple different places in a couple different pieces. This guy, I could write it as 3 times x minus 3. So for our least common multiples of all the denominators in that one, what pieces do we need to have? X minus 3, definitely a part that needs to be there. What else needs to be there? A 3. We also need to have a 6, but do I need to have both a 3 and a 6? No, I can just have the 6. So we could do 3 times 2. Like if you don't want to have to erase that 3, you can absolutely go, oh wait, I also need a 2 in here. So our least common multiple is really going to be 6 times x minus 3, right? And we can do where you come just like we did yesterday and do our fraction with our thing and multiply by ones to get to a common denominator. But since we're in equations, we don't have to only multiply by 1. As long as I multiply both sides by the same thing, I can multiply by whatever the heck I want, including by 6 times x minus 3. So what I'm going to do, and I'm going to write the whole thing out just so we can see it, is I'm going to take my minus 5 over 3 times x minus 3. That's my original fraction. And we're going to go times 6 x minus 3. Let me write the whole thing out, and then I'll go back through the y. Okay, plus our 4 over x minus 3 times 6 times x minus 3. And we're going to hit across the equal sign, too. We're going to have our 5 over 6 times 6 times x minus 3. As long as I multiply all the pieces by the same thing, I can multiply by whatever the heck I want.
So don't you know the denominator will be the same, right?
If we want to just simplify, yes, our denominators want to be the same. If I multiply by my least common denominator, or my least common multiple here, let's see what happens when I just multiply by that instead of by the 1.
No, it's not that. Like, I was thinking, like, because, okay, you wanted to have 6x minus 3, so I was thinking you multiply that by 2, you can multiply that by...
You could absolutely do that.
You can do that.
It's going to leave you with fractions, and then you would wind up cross-multiplying.
Okay.
This is a shorter way of doing that. If we multiply by what that common denominator would be, what's going to happen on this first fraction? The x minus 3's cancel, and the 6 and 3 will simplify, so this is just a 2. So this whole first term simplifies down to be what? Negative 10. Second term. My x minus 3's cancel again, and I'm left with just 4 times 6. So we're going to have plus what? 24. On the other side of the equal sign, my 6 cancels out, and we're left with what? I like the enthusiasm though. Love it. Okay? So yes, you can absolutely do it the same way we did rational functions yesterday, where we were making them common denominators and doing it that way. 100% valid. Will also work. This is less writing. Okay? Let's finish simplifying this. What is my left hand simplify down to? 14 equals 5x minus 15. What do we need to do? Add 15. So we're going to wind up with 5. Excuse me. 5x equals what? 29. So what does x equal? Yeah, 29 over 5. Since we started with x's in the denominator, we have to go back and check. Does 29 over 5 make any of our denominators equal 0? No, it does not. The only thing that would make these denominators 0 would be 3. And 29 over 5 is definitely not 3. So it's important to look, but all we got to do is say, all right, I checked, we're good. Okay? All you got to do for that part is look at it. You do not have to write anything down for it. Can if you want to, but you don't have to. Okay? So we got 3 minutes, so we're gonna not do another one. No. I would love to, but we're not gonna. Okay? So I'm gonna put. Oh, it's gonna. I gotta do the thing where it's gonna freak out on me a little bit.
When is 1 5
1 5 does not exist. We're not doing 1 5. So you go to 2 1.
Oh, sorry. When's 2 1?
Hang on.
That was a little work. That was was on the homework. We never went over it. It was so confusing.
This one?
Yes. I was just random stuff.
Exponent laws. Negative exponent. That makes this a denominator, right? X squared minus 4 to the 1/2. This. So all this is up here. 2x.
I give up.
1/2. That gives you a 2 down here. 2x, right? Exponent laws. They're just weird looking, but it's exponent laws.
There's one every homework, like there's a random
Go
hard
Brian,
question
she's
that has
either-
nothing to do with what we did. But we have to figure it out.
Rarely.
Is it gonna be on this one?
It literally has nothing to do with it. I was so
Oh, like it does?
I was
Like, you don't even have to do any. That's it?
Just smoosh it around. Smoosh it around. It's Play-Doh. Simplify it. You'll have to get to a common denominator to add them. I was like, I did it on my answer key. Like that I'll post. I post the answer key. I'll post the answer key here in about 15 minutes. Okay? What I was trying to get to was that one. Homework 2-1 is going to be due Monday. Monday. Thursday. That's 2 days. We are doing our quiz over sections 1-3 and 1-4 tomorrow. It'll be a single paper again. It might be double-sided just so we have space to write, but it's only because it's like 5 to 6 questions. It'll be okay. Usually the second one's better. We only go up to the rationalization part. There's not a crazy pants one.
We should grade this next